Okay, we're in section 17. We're going to do the examples. Again, I want to emphasize that the way we're doing these problems, there certainly is a variation of it. However, the way we present it to you is the way we'd like you to do it. We also write problems that reflect that procedure that we want you to do. All right, so what we're going to do now is we've already presented the lecture material to you. It's very short. There's really not much to say about that. We're going to do examples. All right, we get time to switch over to the whiteboard, and I'll do examples at the whiteboard. Okay, we'll start with the first example. And let me just select it, pull it to the side, and I'll blow it up. All right, whoops. Okay, the method we're going to recommend is you're going to look at the major fraction bar. This is the major fraction bar. Within the major fraction bar, you see the smaller fractions. These are the minor fractions. Of the minor fractions, denominators are just 3 and 2. So we need to find the LCD of the minor fractions. I'm going to call it the minor LCD. And the minor LCD is going to be, well, between 3 and 2 would be 6. What we're going to recommend you do now is multiply the top and the bottom by the minor LCD. All right, I'll write that down for you. It's going to be 6 gets distributed across the 2 terms on top, and the 6 gets distributed across 2 terms on the bottom. Let me write that down for you. 6 times 2/3 plus 6 times 3/2. I realize some students may argue, do I need to write that down? No, personally, I wouldn't write it down either, but the bottom line is we want to emphasize what you're doing. I'm going to do it on the bottom now. 6 times 2/3 minus 6 times 3/2. All right, let's see if we can do it. And I'm going to do some reductions. So 3 goes into 3 once, and it goes into 6 2 times. 2 goes into 2 once, it goes into 6 3 times. 3 goes into 3 once, it goes into 6 2 times. 2 goes into 2 once, excuse me, it goes into 6 3 times. Let's do the arithmetic. Should be very simple to do. And what would you get there? You would get 4 plus 9. On the bottom, you get 4 minus 9. This would give me 13. And 4 minus 9 gives me minus 5. All right, that shouldn't be written that way because we want the bottom number to be positive. So we either put the minus sign on the level of the fraction bar or on the numerator. I realize someone's going to say, I don't want to do that method. You could do another method, and I'll write it down for you. It's going to give you the same answer. 2/3 plus 3/2. 2/3 minus 3/2. Whoops. Let me make sure that doesn't look as bad as I think it does. Do the arithmetic on top, and that would be a common denominator of 6. And what would you get over there? 4 plus 9. Do the arithmetic on bottom, common denominator would be 6. What do you get there? You would get 4 minus 9. You should see some similarities between these two methods. This would be 13 over 6. This would be minus 5 over 6. This is 13/6 divided by minus 5/6, which is the same thing as saying 13/6 times minus 6/5. What cancels off there? A 6. What he left off with? Minus 13/5. Right? Do we get the same answer? Of course we do. All right, let's go to the next page. Make sure we're staring at that answer. And we are. We're staring at minus 13/5. All right, let's look at number 2. Again, what I'm going to recommend is the method we've discussed in class, which is to write down the minor LCD. Right? I want to point out what I mean by that. This is a major fraction bar here. These are the minor fractions right here and right here. What's the denominator x squared and x in both cases? So the minor LC is simply just x squared. What we recommend is to multiply the top and the bottom by x squared. I'm not going to do a lot of writing this one. I'm just going to go through it. So this x squared gets distributed across these two terms. So, x squared times the first term, well, the x squared would cancel off. I would just get 8 plus. Now, if you do x squared times the second term, one of the x would cancel, and you're left off with 8x. Let's go to the bottom. What do you get there? Well, x squared times 5 over x squared would just be 5. And the next term would be, well, one of the x would cancel, you've left off with 5x. Now, I realize some students say, oh, that's the answer. I'm not saying it's not the answer. What I'm looking at is maybe there could be something to do here. All right. So what I'm going to do is I'm going to factor the top. 8 comes out. You're left with 1 plus x. Factor the bottom, you get 5, 1 plus x. What do I know now? There's a cancellation. And what are you left off with? Something pretty simple. You're left off with just 8/5. By the way, this is conditionally true. You don't have to write it down, but the condition is x can't be a 0 or -1 for that to be a true statement. Don't worry about that, though, if you understand what I just said there. So I'm going to point out here, you got the answers. All right. All right, let's keep going. And I'm going to number 3. All right. So again, the thing about here is that we're looking at a major fraction bar. There's only one minor fraction, and it's got a denominator of a. So the minor LCD, whoops, let's go back to black ink. Is a. What do we recommend? Multiply the top and the bottom by a. Let's go through that. And when I do that, I want to point out what I'm doing. I'm using the distributive property of multiplication. This a distributes across both of those terms. I'll write that down for you. That's a squared minus 7a. And I'm going to distribute the a across the bottom two terms, which would be 49 minus a squared. Again, a lot of students say, oh, I'm done now, and they put a box on it. But let's see if we're done. I'm going to try to factor it. And you get a minus 7. On bottom, you get 7 minus a, 7 plus a. All right, this might seem a little tricky to you, but something we've done, a long time ago. And that is, I see factors in top and the bottom that are actually opposites. All right. So I'm going to point out that this 7 minus a is the opposite of a minus 7. And when they cancel off, it would cancel off to -1. So I'm ready to write my answer down. It's going to be minus a, because -1 times a is minus a. And the bottom is 7 plus a. I'm going to write down a plus 7 instead, though. But the same thing as saying 7 plus a. Look at the answer and see if you got it. And you did. Now, if someone says, why they put the minus sign on the level of the fraction bar, you can, or just put it at the top. All right, either way. All right, let's look at number 4. And again, the procedure is going to be the same each time. And what's that procedure going to be? This is a major fraction bar. These are the two tiny fractions in it. They're called minor. What's the LCD of the minor? Well, there's only one denominator. So the minor, let's go back to black. Sorry about that. Is just x plus 3. What are you going to do? Multiply the top and the bottom by that minor LCD, which is x plus 3. Let's write that down. I want to emphasize what we're doing here. We're taking this, we're distributing across these two terms. So it's going to be 5 x plus 3. That's the x plus 3 across the first term, minus, well, what's nice about this is by multiply the second term, the factor x plus 3 would cancel off and left off with 15. Let's do the bottom. What do you get? 7 x plus 3. Minus, well, that second term times that x plus 3, the x plus 3 would cancel off, you get 21. Again, some students say, oh, I'm done now. Maybe, but I think I can do something else with it, right? What do you get? 5x plus 15. I'm distributing because the 5 across those two terms, minus 15. On bottom, you get 7x plus 21 minus 21. What do you get there? 5x over 7x. And what do I see? A cancellation of an x in both of those terms, right? What do you get over there? 5/7. Let's look at the k and make sure we're staring at that. And we are. So next one, a little more complicated, but still going to be the same procedure. And again, simply say, what is that procedure? That procedure is you should recognize there's a major fraction bar here. And within the major fraction bar, I see two minor fractions. What's the LCD or the minor LCD? Whoops, did it again, didn't I? Is, well, 2x plus 7, that's kind of easy, right? What are you going to do? Multiply the top and the bottom by 2x plus 7. Let me go through that with you, and I'll write it down for you. Now it's going to be x, the first term, times 2x plus 7, minus 2, that's the second term, times 2x plus 7. The third term is pretty easy, by the way. And why is that? The factor of 2x plus 7 would cancel off, so you get plus 9. We'll simplify that later. My suspicion is going to simplify nicely. Let's do the bottom. First term is x times 2x plus 7 plus 3 times 2x plus 7. That's the second term, by the way. Minus, what happens there? Again, the factor of 2x plus 7 would cancel off, minus 1. Let's keep moving forward. Again, if you're faster at that, that's great. If you're not fast at it, just take your time. You can always come back and rewatch these things if you need to. All right, so what do you have here? 2x squared plus 7x minus 4x. I'm just simplifying the top. Minus 14 plus 9. On the bottom, you're going to get 2x squared plus 7x plus 6x plus 21 minus 1. Again, my suspicion is that we write problems that should move forward. All right, now, since it's way too much work, consider it. I mean, you really want to do work. You want to show some progress here. So let's write this down. On top, I get 2x squared. And let's see, you get 7x minus 4x is plus 3x, right? And minus 14 plus 9 is going to be minus 5. That wasn't so bad. The bottom, 2x squared plus 13x plus 20. Again, I'm not saying that's not the answer. It could be. What I'm saying is I wonder if there's any more work for me to do. And my suspicion is there's probably more work. All right, I haven't even looked at the key yet. So let's see, what would that work be? I try to factor it, right? Let's see, I'm going to say 5 and 1 plus and minus. And I would never say that's right until I try it. So let's go through that. 2x times x is 2x squared. Minus 2x plus 5x is plus 3x. And we do get minus 5. That worked beautifully. Let's go to the bottom. A little more complicated, but I'm looking at the 20, and I'm going to say probably 4 and 5. Now, if I said 4 and 5, I want to be honest with you, the 4 would not go here because it will be a factor common with the 2, with the 5. And again, I'm not saying it's right. I'm just saying I'm willing to try it. I say plus plus, and let's see if it works out. 2x times x, 2x squared, that worked beautifully. 8 plus 5 is 13. That worked beautifully. And we get plus 20. What do I now notice? A cancellation. And what do you get in the end? Something pretty simple. You get x minus 1 over x plus 4. And that's it. All right. What are we going to do now? Look at the answer key. And we should see x minus 1 over x plus 4. Right there. Okay. So what do you need to do? Well, you probably say, I'm exhausted already. You got to start trying. And what are you going to try? You're going to try to do the homework. All right. My guess is the homework is going to look just like we did in class. But you have to practice this. They've got to practice it. What does it mean? Do all the problems that follow. And by the way, there's answers over here. Just don't simply say, oh yeah, gee, that's right, do no work. You want to do the work as we've outlined in class, right? You should do every single question. If for some reason you can't get these questions, come by during office hours and I can help you with it. Furthermore, I will be publishing videos, right, later in the week, me at the whiteboard doing the homework. All right, thank you.